Well, welcome everyone back to Data Science and Technologies after our spring break week. And wanted to start off with a weather announcement. Now, this does not impact us today because today is a beautiful spring day. But this just went out from UA Little Rock Communications, and we are anticipating heavy rain and the potential for severe weather this week. So a couple of things I want to make sure students are aware. It is important to monitor your local forecast. So this is a good time. Some of you may have a weather app on your phone. If not, weather.com or AccuWeather or the National Weather Service are all good sources of information. And we're anticipating maybe around 7.5 inches of rain starting sometime on Wednesday and going through Saturday. Now, I don't think the rain is that much of an issue, but, and this is where you really want to have the weather alerts. We do have a chance for, and this is the key thing, for tornadoes. Wednesday is the day to really watch out for. But Thursday, you are welcome on Thursday if you'd like to join remotely. And that's important because even though we probably won't have bad storms on Thursday, hey, if we have drenching rain, it's a real pain to have to make the trek. So, and then of course, Friday, again, they're talking maybe drenching thunderstorms, and Saturday again. But I think it's Wednesday is the day they are most nervous about. Okay, so so a couple of things. Yes, just allow extra time, or let me put it this way. It is fine this week, in my classes to be remote. And but it's important to keep your devices charged. We might have power outages. Also, stay alert for any campus weather updates. So anyway, that is what's going on. And I was going to say there are a lot of weather alert apps. So I was going to say, and this can be a good one. The apps are good, particularly at night. I've got at home. I've got actually a weather box, and it will, if there is a tornado warning, it sounds an alarm. So make sure that I'm woken up so that I'm aware. So anyway, but there are a lot of, you can kind of look over, and yes, that is something to actually kind of fits in to today's topic because we are going to talk about Internet of Things. And of course, one of your biggest Internet of Things is your phone. And, one of the things, the reason why you can get severe weather alerts for your location is that your iPhone has a variety of sensors. And in particular, it can, in terms of, for example, being able to tell your location. And that can be very useful. That is why it kind of knows where you are and what a weather alert you should be receiving. Okay. All righty. So that was the most important announcement. And then let me just mention, and here, let me go and switch over to the whiteboard So we are kind of getting into crunch time in the semester. So what are some of the crunch items? Okay. So these are the crunch items. Okay. Okay. So first crunch item is, of course, be sure you are keeping up with your assignments and getting them submitted. So that's important. Those are things you can be knocking off on a weekly basis. So the second crunch item is that you've got a paper due at the end of the semester. So we've been talking about that a lot, and there are instructions in Blackboard Collaborate. We've got guidelines in the content area. I believe one of the very first folders is the Data Science Project Report and Presentation Guidelines. So just go into Blackboard Collaborate, go to the content page. It's the second one from the top. So, but this is really important. You have a month left to develop your data science project. Write write up your report and do a 3-minute presentation summarizing your work. Okay. So this is really important because you really do, you need to spend a month on this. So just, and by the way, I know a number of people have already actually not only started their projects, I've had 2 or 3 people actually finish their projects. But keep in mind is if you have not yet gotten your topic, you got to get a topic this week. And probably the easiest thing to do if you're in a bind and you're like, well, what do I do? Is at this point, if you haven't gotten a topic, try Kaggle and find a data competition, either current or past, that interests you. Okay. And let me just give you the outline of what you need to have in your report, and this will give you an idea of what you need to make sure that you need to do. So, so your first step is you have to do some background research on the topic. And I'll just make a note, keep track of your sources, because this is what you can put in your reference list. So this is really important. As a data scientist, you don't want to be analyzing blind. I mean, you don't want to grab a topic that you know absolutely nothing about, grab some data that you know absolutely nothing about, run it through some models that you know absolutely nothing about, and then try to convince someone that you actually know what you got. Okay, so you've got to first of all do some background research on the topic. And then that's part of something that you have like the next week to do, and then you have to do some background on the data set itself. So that's very important, because once you have your introduction to the topic, you want to tell the reader about the data. And that means more than just saying, hey, I got this data from the URL. I mean, that's like telling your mother that, you picked someone up on some back alley in some part of Little Rock. I mean, we need details. So you got to be able to tell us, where did this data set come from? What's the history of this data set? Where did Kaggle get this data? What are the attributes? How many rows does it have? What is the meaning of these attributes? You might also want to talk about what's the condition of the data set. What sort of cleaning is necessary? What are is there a key attribute that you may want to use as the Y variable, the thing you want to predict or classify? In terms of the other variables, which ones do you feel are going to be useful, explanatory, X variables? You don't necessarily have to use all of the attributes. There are some attributes you may decide you don't need. There may be attribute names you want to rename. So this is the part where there's a good story you can tell about how you got, once you explain what the problem was, you then explain, well, here's how I got some data and got the data into shape for doing some analysis. Okay. So now we're getting, at this point, we're getting into, mid-April. So now what you need to hustle up and do is work on your analysis. And there's, again, a couple things you could do. You could start off with an exploratory analysis. Then you could say, maybe you're looking for some associations or, possible root causes. And then you might want to try out a few classification or prediction models. Again, that's a great story that you can tell. What sort of pie charts or bar charts, what kinds of visualizations did you do to kind of understand how your various attributes behave, how would you describe them? And then in particular, if you're trying to predict or classify something, what's the associations? Which of your explanatory variables seem to have the strongest correlations or associations with that Y variable? Maybe you want to try some box plots to see even between your classification variable and some of the qualitative variables. Are there any relationships? And then we covered a number of resources that show you a number of different machine learning models. So think about maybe you want to try out a regression model. Maybe you want to try out a random forest decision tree. Maybe you want to try out a neural network. So this is where you can kind of tell a nice story about how you explored your data, how you looked for what variables might have the strongest association or correlation or causation with your Y variable. And then, what are a couple models that you wanted to pick out from the Python libraries just to see which one or one seemed to do a good job in making that prediction or classification. Okay. So now you basically get now to the last section, and this is where you want to be working the last week of class. You want to be, sort of summarizing what you learned, what you did, what other things might you want to try in the future, and what are, potential uses of your work. I mean, you just maybe came up with a fairly decent way to predict or classify. How might someone put that to work? Okay. And this is where you want to be the last week in April. You don't want to be starting your paper. You want to be finishing up your project, finishing up your paper, and now working on putting together a 2 to 3 minute summary, just giving the overview of what you did. And don't forget, documentation is really important. So this is where in your appendix, think about things like you want to put your references, your sources. You want to think about thinking about other things that you could do. And this could be, by the way, a separate attachment. Maybe you want to include a copy of your code book. Maybe you want to put this is always good. How about a work breakdown structure, basically an outline of the hours you spent. And by the way, as I say, sometimes it's easier with these code books. Put that in maybe as a separate attachment. Sometimes that's easier. But thinking about this is good. Keep track of the hours you spent. And your references and sources, your reports really aren't going to be necessarily journal articles. They just need to be a good data technical report. And so think about, maybe your sources, you took inspiration from blogs, maybe you took inspiration from tutorials, maybe you looked at some other notebooks. That is all fine. This is what you want to document. You want to show, hey, in order to do this work, I read, 3 or 4 articles on this topic. I then had to look up information about some of these different machine learning models. So I had a bunch of, tutorials on that. And then, I needed to write the code, and I found a couple good blogs that kind of walked me through the code. So this is where you want to list all of those references. You want to say, hey, this is the URL, this was the title, this was the author, this is the date. I really want to document the sources that I used. Okay. And right now, if you start this week and identify a Kaggle challenge maybe this evening and start with the background, you'll be in great shape. Come the first week of May, you'll be just submitting your work and saying, man, now I can spend time, on my other classes. But let me pause for a moment, see if there are any questions, concerns.
Professor, my question is about the workday homework.
What was that? Yes.
Yeah, what are we supposed to do?
For what?
On the workday homework.
So which homework?
The workday.
Oh, the workday.
Yes.
Okay. So for the workday homework, we actually covered that in class. So okay. I'm going to refer you back. We actually covered that assignment in detail before spring break. So yes, you've got to go back and watch the recordings for that.
All right. Okay.
And and I'll just say that's super important. That's another good announcement. If you are planning to be here, one of two things. Either you're graduating this spring or summer, and we are actually past the deadline for the spring graduation, but you can still go in and apply for summer graduation. So if you can show me, hey, I'm graduating, well, then that's fine. Show me a screenshot that you applied for graduation. However, if you're going to be here fall 2025, then you need to register in Workday. And that's going to be a big deal. And it's going, let me put it this way, this is another area you do not want to procrastinate on if you're going to be registering for fall 2025. If you have not done so already, you need to make sure you have access to Workday. You need to make sure you have completed the onboarding and shown, that's the other piece. Show me you've completed your onboarding. And I cannot stress this enough. If you're going to be here fall 2025, make sure before you leave campus, for the summer, make sure you have talked to your program advisor, Make sure you've gotten your advising flag lifted. Make sure you've gotten your list of classes that you're going to take this fall, and make sure you have registered. You do not want to be one of these people that show up the day before classes to say, hey, I'm ready. What do I do? Because I'm going to tell you right now, that's like showing up on the deck of the Titanic and saying, hey, I'm here. Where's the pool party? And, people are going to be running for the lifeboats. So I'm telling you, the stress levels are going to be super high on campus. You want to be the person who has your classes, you have your schedules. You want to be the one, kicking back, relaxing. So just add that to your to-do list. And as I say, we have a recording where we went over this, but I will just say that is, let's put that down as item 0. Yes, the one good thing is that is a really good reminder. Be sure you have applied for spring, summer graduation, or gotten your classes set up in Workday for fall 2025. Yeah. Okay, so that's good. Excellent. And by the way, we do have the recordings. Let me, some students may not be aware. Let me just make sure that everybody knows you can do this. Okay, so just a reminder. Okay. All righty. So just a reminder that you can go down to the class collaborate, click on the Twinkie, click on view all recordings, and notice you can even check out, you can even say, you can see 313, we looked at Workday Student. So, and I've tried to give all the titles meaningful names, not recording 1, 2, 3, because like who remembers what that is, okay? But that's really important, and you can go back and you can play any of the recordings, and you can go back even further. You can say, oh, wait a second, let me go back all the way to January, yes, and you can get all the recordings. So definitely, but that's a really good reminder. Any other things? Yeah. Okay. How about the folks online? Everybody good there? And you can do this just about for every class. So we take advantage of the recordings. Okay. All right. So what we are going to do is we're going to start introducing the area of streaming data and the Internet of Things. And so I'll introduce the topic today. Dr. Phil Williams is coming out on Thursday. He's going to do a demonstration using a Raspberry Pi sensor network. And then the following week, Dr. Dagtus is going to talk about some of his research with working with IoT sensors. This will also transition very nicely to our next topic. Is we'll take a look at the AWS platform, because if you wanted to build a streaming data application, and let me just see, software for streaming data. Okay, there we go. I wanted to look this up before class. So it turns out that when we talk about streaming data, we're really talking about all the sensors that are out there. And we mentioned the phone. You know, your phone is a source of streaming data. So it's considered Internet of Things. Think about if you have a Ring doorbell. Your Ring doorbell is streaming, for example, video when somebody comes to your front door. Think about all the cameras that are being put out to take, for security and for other reasons. Think about camps that have been set up to stream images. Think about motion sensors. Think about the sensors that are being put into your car. That, for example, if you want to use some of these insurance apps, they can monitor your driving. And based on the data streaming from your vehicle, they can kind of calculate, are you a high-risk driver or a low-risk driver. Kind of interesting, I saw something on the news, they're worried about sort of habitual speeders. And sort of, one strategy is, putting a device on the car that prevents them from speeding. But, another way of monitoring them is basically having sensors to kind of be able to tell, how fast they're traveling. As well as, sensors, because my car not only tells me how fast I'm going, it actually picks up the speed signs, and it will tell me, I'm going 35 miles per hour in a 25 mile per hour speed zone. We've got sensors that can detect moisture. We have sensors that can detect salinity, in the water, water quality. There are sensors that can be streaming off of equipment. So everything from sensors on airplanes to tell us, what's going on with the engines, sensors on manufacturing equipment as to, what's going on with the, in terms of wear. We've got data streaming from, all the luggage tags that you can, put on things. I mean, kind of the list goes on and on. We are really at the point that we can take a lot of objects and we can digitize them. We can put a sensor on a parking space, and this sensor can register, whether it's open or whether it's covered, i.e. a car is parked on top of it, so the space is occupied. That sensor can be streaming that information. So now all of a sudden we can take that parking space and we could build an app around it, in terms of, helping people find available parking spaces quicker. So our ability to kind of put sensors on our kids, sensors on our pets, sensors in the outdoors, sensors on the indoors, basically have opened up a lot of new applications or ideas of how we can make use of that information when all of a sudden we can basically put some sort of data transmitting device on an object, whether it's a chair or a table or casinos. Casinos will put a sensor into the casino chips because they are interested in understanding how gamblers, are using or, moving these chips and how they're moving from one part of the casino to the next. So, and they say very interesting. And when you start talking about all of that streaming data. So imagine, Las Vegas and a big casino, and they've got thousands of gambling chips that they are tracking their movements of. We are talking really big data. And the question becomes, okay, how are we going to process and work with that data real time? So this is the challenge, because a lot of times with the Kaggle data sets, we're talking about batch data. We're talking about a data set that has been gathered and curated, and it is sitting there like a data lake. It is sitting there, and we're using that data maybe months or even years after that data was created. So it's like a lake filled with water, and that water may have been in that lake for years and years and years. But with streaming data, think of it like a data river. This is data that is streaming past us, and yeah, you could dam it up or batch it up, but that's not let me put it this way. We have done that with data lakes. What we're interested in is using that data to tell us what is the situation right now, and how can we use that for real-time decision making. So in order to create these streaming data applications, one thing we need to talk about is this is when one computer now is really no longer enough. And so we're definitely going to have to look at platforms where we can take a number of computers and put them together as a cluster. And then we need special software that has been designed to take in this sensor data and to be able to take that stream of data and to help us analyze it and find patterns or signals that we can use for real-time decisions. And so we're seeing things like Kafka, Amazon Kinesis, Google Cloud Data Flow. Again, some of the open source are Apache Flink, Apache Spark, Azure Stream Analytics. These are all software platforms that you would want to then install on top of your distributed computing cluster, so that you can then hook it up to your data pipelines and be able to work with your data. Okay, and notice there's a bunch more. Okay, so as I say, talking about streaming IoT analytics, I mean, we also will need distributed computing for working with massive data lakes, and of course that's sort of the same underlying platform with maybe different types of software for working with huge amounts of batch data. But as I say, it's getting, when you start thinking about all the data that we're streaming, this gives you motivation for why we need to start thinking about tying our computers together into teams, so that we then can have the right type of software in place to be able to work with that streaming data in real time. And then we will wrap up the semester looking at data science, ethical, sustainable legal issues, and then really the first week in May is really just about turning in your work. Along the way, as I mentioned, Dr. Phil Williams will be here, Dr. Sirhan Daktas will be here, and around April 22nd, about the time that you're working on finishing up your data analysis, I'm going to have Dr. Ning Wu do a guest visit. Dr. Wu in our department does a lot with data mining, and she's a great student mentor, and one of the things that she's often had to wrestle with her students is, how do you fit a model without overfitting? And so she'll talk about, how can you figure out when you've gone past the point of a good fit and now you're just simply memorizing the training data. So on the surface, it looks great. It looks like you have 100% accuracy, but in reality, what you've done is you pushed the model too far. And so she's going to be talking about how that happens and how you can detect it and how you can, correct for that. Okay. Okay. And I should mention, just in case we don't get a chance to discuss this on Thursday. So I was trying to think what would be a good IoT streaming assignment. Because again, at this time of year, I want folks to be really focused on working on your data science project. So I had originally found this neat little quiz. And it was there at the beginning of the semester. And you'll notice it's not a good sign when Google just searches and searches and searches. Because I was like, oh no, it disappeared. But I did find, just shows you nothing ever disappears on the internet. I found this same quiz on another site. And I was going to say what we can do here is, so the quiz shows up on the left-hand side, and what you do is, this is kind of nice. So you just have to click on the quiz question. So, so through which network does Open IoT manage registration deployment of sensors? And by the way, you're welcome to Google. That's fine. You can try it out, and you can say, wasn't HTTP, it was something called XGSN. And what I want you to do is go through the list of these questions. Okay. And there should be, just see, there should be 50 of them. Okay. Now the point of this exercise is you do not have to tell me which questions you got right and wrong. What I want you to do is go ahead and go through the quiz. Again, you're welcome to Google, see how many you can look up. And then what I want you to do is write up a couple paragraphs kind of describing your experiences with this quiz. So you can kind of, tell me, which types of questions did you do real well on? Which types of questions, gave you the harder time? Which areas would you like to know more about? And so this is just kind of giving me a paragraph or two of a reflection, just demonstrating, hey, I did go through the quiz, and it's fine. If you want to report, I got, 40 out of 50 correct, that is fine. But in order to get full credit on the assignment, you don't want to simply say, here's my answers. And you don't want to simply say, hey, I got, 42% on the quiz. What I really want to hear is your reflection. Tell me a little bit about, what is your sense of, of your, current knowledge when it comes to the Internet of Things. Okay, and then you can essentially, submit your reflection to the assignment folder. Okay, so let me pause. Any questions about that? So that is just taking an IoT quiz and just assessing, what's my current state of knowledge with that? And, even Googling is fine because if nothing else, you'll get a sense of, oh, how easy was it to look up this information? Where did this information come from? Oh, what did I learn from looking it up? You're welcome to give ChatGPT a shot. How well does ChatGPT know about IoT? That is fine. Okay. All right. Seems pretty quiet. So let me just then move on to the some of the class materials. So I've got a couple of things, and again, what you want to do is kind of make sure that these class materials, I use them in part for presentation, but a lot of times we're not going to cover the entire article in the class, but they are good resources. So definitely as part of your homework, and you may want to take a look at some of these, before you do the IoT quiz. Kind of take a look at what people have to say. Okay, so we talked a little bit about what is data streaming. We talked a little bit about the examples, and we talked the importance, as I say, and I should mention, one of the things that's different with streaming versus batch is with batch data, think about it as a data lake. We're essentially storing data. But if you're talking about a river, we don't really talk about storing a river. The river is flowing past us. And what we're doing is just, as I say, kind of taking a sample, out of the river, at a given point in time. So notice with data streaming, it's really not about massive storage. It's about the velocity. How quickly can we get whatever signals we want out of this stream? Okay. And so they have some characteristics between batch processing and stream processing. I did find kind of a nice visualization here. Let me see if that's still, oh man, did that also disappear? Oh, no, here it is. Scared me for a second. Okay. But when you look at the difference between batch processing versus data streaming, notice here, typically we're taking data and we're loading it into some data repository. So this could be, might be a relational database, but it doesn't have to be. It could be a not only SQL database. It could be MongoDB. But basically it's some sort of data repository. And if you look at batch processing, what we do is, we'll have a question. We want to do some exploratory data analysis. So we do that processing and we get some results. Oh, now we'd like to do something else with that batch data. Maybe we want to do some correlation analysis. Oh, okay. So we'll do some correlation analysis and we'll get our results. Oh, now we want to do some more processing. There's something in our batch data we want to be able to, look at historical predictions or historical classifications. And so what we're going to do is, we're going to try a neural network, or we're going to try, an XGBoost or an SVG model. We want to do some sort of cluster analysis. We're going to do processing and we're going to get the results. Okay. So that's the traditional batch paradigm. With data stream processing, we have real-time events. And what we're doing is typically we're looking at a window of signals. And based on that window of signals, we're asking ourselves, hey, is there a motion there? Is there, a salinity reading? Is there a temperature reading? Is there a speed reading? And what we're doing is then getting live results, and we're trying to use that for live, maybe we're using it for live monitoring, live tracking. Maybe we're trying to use it to, again, motion, for example, a moisture. I've got a sensor now. I've got a new water heater a few weeks ago. There's a sensor at the bottom of the water heater pan, and it's basically sitting there waiting for a signal that it's wet. Because if it's wet, that means my water heater is leaking. And I'm going to get an alarm to alert me that, hey, your water heater pan is starting to fill with water. You better, get up there and be able to, shut off the water and call the plumber, okay? And, it's supposed to do that, before it overflows and causes damage. So this is what we're talking about is, live results for real-time analysis, real-time monitoring, real-time decision-making. Okay. So these are some of the other characteristics. And you can see some of the benefits that people use with streaming data, everything from marketing. It's used healthcare. My goodness, you go to a hospital now and they have the patients, hooked up to all kinds of things, monitoring their oxygen level, their heart rates. And this all gets streamed to the central nurses station. So nurses can kind of keep an eye. And again, there are beeps and alarms go off to alert the nurse when a patient's biometric signals go outside the desired normal parameters. Okay. And it's interesting. They talk a little bit, streaming data has security issues. It has privacy issues. Trying to figure out, is there anything we want to store from this streaming data? And if so, how long do we store it? Do we store it at all? These are a lot of the things that we think about when we're trying to build a streaming application. Okay. And again, this talks about some of the popular frameworks, and this is coming from a company who has offered services. Okay. And again, you can go from a small system, Dr. Phil Williams works with some IoT systems where he just has a couple sensors. So you can think of that as an IoT trickle. It's a tiny little just a trickle of data. But you can imagine as you add more sensors, it goes from a trickle to a creek to a larger stream, and eventually it can become, a river. So that's a great overview. If you haven't really had a chance to look at streaming data. Okay. The other good background reading, just getting you ready for the homework for Dr. Phil Williams' demonstration and for Dr. Dagtus next week. Tutorials Point is kind of nice. They have a nice overview of the Internet of Things. And again, couple of things that we're looking at is, the ability to employ these devices. I had read somewhere that one of the fast trends in the home building industry are smart homes. And smart homes are basically nothing more than putting IoT devices into your home. And so that's become a whole specialty area. People who install, systems for monitoring your thermostat, for opening and closing your windows, to adjust for sunlight, to be able to monitor. It goes beyond just security, but basically monitoring your appliances. So installing these different packages, maintaining these packages, helping to monitor and service these packages has become, that's become, a whole industry. Okay. Okay. But again, this is a nice, easy to read article. And again, it shows you, these sensors. First of all, they kind of give you an idea of what some of these sensors look like. But they also include wearables. So if you have a watch, you have a phone, there was a really interesting article on the news the other day about, will people get to the point that they're really looking to put computer implants into their bodies for a variety, not just medical implants, but implants that might, for example, help you connect to an AI system. I mean, it's almost like science fiction, except it is now really becoming sort of a science fact. And by the way, if you're curious, you can just go out to Amazon and you can look at, I bet, IoT sensors. Okay. Okay. Amazon, you can get IoT sensors kits, and they've got all kinds of little kits that you can use. They've got kits for all ages. They have kits for doing robots. You've got I don't even know what this is. This is a this has this one actually even mimics a little smart farm. Wow, I think they even have a little thing where you can actually grow some grass seeds and kind of monitor. So let me see if they have. Let me just see if they have some examples of sensors. Okay. Okay. So your sensors can look like all kinds of things. I mean, here's one that is just a weather sensor that will sense a whole, a bunch of different things. But you can get different. You can use drones. And it really just, depends on, here we go. The sensors can just look like small little circuits. The sensors, it kind of depends, what you want to, basically it just depends, what do you want to sense? Are you looking for sounds? Are you looking for light? Are you looking to pick up some sort of chemical detection, like carbon monoxide? Are you looking for the presence of salt in the water? Looking for nitrogen in the water? So it really just depends, what kind of information do you want to pick up? And then it's just a matter of designing a sensor that has the capability of taking in whatever it is in the environment that you want it to pick up and doing the analysis and then being able to relay the signal through some type of wireless network to get that data, to your network site to receive the data and to process the data. Okay. And so, to do that, typically you've got to have then the software that basically is going to allow you to collect that data from potentially multiple devices and then be able to process and work with the data. And then maybe you want to distribute the results to other places. Okay. And so again, this tells you a little bit about some of the IoT communication protocols. It talks a little bit about some of the different architectures that you have to choose from. So you've got basically the sensors that are going to do the sensing. And then, of course, you've got to figure out some sort of network in order to get those sensor readings from the sensor to where you're going to receive and process that data. So now you've got your processing. And then what it is, now that you've received and processed that data, what do you want to do with it? Do you want to, you could store it, you could analyze it, you could display it on a dashboard for real-time monitoring. You may want to, maybe you detected a signal and now you want to relay that information to an alarm system. So you have to think, okay, now that I've gotten the data, processed the data, what do I want to do with the data? And then this is really interesting. This area down here is just what are some common uses. And you see everything from engineering, government, safety, home and office, health and medicine. Check this out. You can use it for media, marketing. Maybe you're using facial recognition, and as people walk by a kiosk, you're tailoring your commercial content for the group that's walking by. Building, housing, transportation, smart cities, traffic control, education applications. I even saw an application where they were thinking about, well, could they monitor the kids' movements in the classroom? And when kids start to fit too much, maybe that's a signal that it's time to, do an activity. Let the kids get up, move around, work off that energy so they can get back and concentrate. Law enforcement, and you can see then some of the different protocols and some of the specialized topics in this area. But that's a great overview as well. You don't need to see that anymore. And the other things I wanted to show you is, so I mentioned, so what do you do with this data? And here, I can maybe open up this image in a new tab. There we go. So here's an example. If you had, this is very common now. A few years back, Entergy replaced my traditional energy meter with a smart meter. And unfortunately, they did not give me a nifty dashboard to go with that smart meter, but I'm sure that Entergy has the dashboard capabilities where they can look at homes or neighborhoods and be able to monitor things like energy consumption, voltage and frequency, looking at the power, the current, looking at a variety of different charts, seeing if there are any alarms, particularly if if we have storms and we lose power, usually I'll get an alert on my phone, hey, we've detected a power outage. And a lot of times they can even quickly tell me, oh, we've detected not only your outage, but we've detected, they'll give me a number. There are 1,625 homes in your area that are currently without power. And in fact, one of the things you can do is go to the Energy website during a storm or after a storm, and you can see the outage map. Okay, so again, a lot of that data now is coming from smart meters, and the reason they want that is because they want to stream the data in real time. Okay, so there are things like there are IoT vendors like ThingsBoard. And what they will do is you can buy sensor systems. You can buy the sensors. You can set up your network. You can actually have the signals go. ThingsBoard, you can even get an account with them to have the data from your sensors, going to their hosting service, and that data essentially gets collected into your account. And then what you can do then is you can basically bring up a dashboard that you can customize, so you can create your own individualized dashboard of visualizations based on your sensor data. And again, you can subscribe to a vendor so that they will even provide the hosting in terms of the computing power to help host your data, store your data, and be able to manage your data for everything from visualizing, maybe doing device management, if you want to actually interact with devices and data. Again, depending on, energy usage, maybe if you're using too much energy, you now want to turn down your thermostat or, turn off certain appliances. And so this is, again, security on who gets to see the dashboard, and and then just, essentially building a dashboard. Okay. And again, if you are kind of looking to say, oh, could I do something like this for a project? Well, the answer is yeah. I mean, you can go to again. Let's just see. Let's see. Are they on? This was. Let's just see. Oh, it's ThingsBoard. I'm just curious if they are. I'm just curious if you can get a kit. Okay. They may not be on. Doesn't look like they're on Amazon, but okay. But you can actually, one thing they do have, let me put it this way. You can take a look at what they have, and maybe you have an idea, because they do. It looks like they do have sort of a free level. So this is interesting. I think they have a how-to. So if you wanted to get started, yeah, they've got tutorials and yeah. So it turns out they kind of have a how-to guide on, if you want to start playing around with IoT, everything from how you could connect a device and be able to upload your data and be able to, use a basic dashboard to monitor. And as I say, you can also kind of get kits on the internet. But yeah, if you are interested in playing around with IoT and you wanted to say, oh, is there a way that I can just set up a simple little IoT project using the open source community platform, and I just want to play around and see if I can create a simple dashboard? As I say, they've got a community edition, and they have basically there's instructions for how you set up the IoT. And also, Dr. Phil Williams will be here on Thursday. So if you're wanting to say, well, is there a faculty that could help me maybe get some of the data from their IoT projects and kind of work with it? Yes, definitely give Dr. Williams a call. Okay, and the last thing I want to show you, we mentioned that why we are concerned about where jobs are going to be going in the future. Certainly, becoming an IoT developer is a career path, and I mentioned earlier in the period that you have folks in the construction industry who are specializing in helping homeowners turn their homes into a smart home. And so I wanted to find this because this has some tips on what are the things that go into becoming an IoT developer. So it turns out, languages like JavaScript, Python, or C, or C++, can be very helpful. You need just some simple basic coding and scripting in order to provide the instructions for how you want your IoT devices to process their data. Getting to know the various sensors, actuators that are going to collect this information, and then also the microcontrollers, Arduino, Raspberry Pi. So the sensors will collect the data, but then, a lot of times, you want to do the processing right there where the data is collected, including maybe even the decision to, send a communication or not send a communication. Or maybe there's certain things you want to do with the sensor reading before you make the decision to send it. So that means that if you're going to have some instructions, it needs some sort of computing, some microcontroller to basically at the sensor level to decide how to process the data. Okay, and then we talked about the dashboards. Yes, one thing to think about is, okay, when the data gets collected, it gets sent through the network, it ends up being processed, we want to then make use of it. Yes, the designing the dashboard so people can interact and work with their real-time data. Yes, we can see that we've got to look at Wi-Fi, Bluetooth. We have to look at network protocols that are specifically set up, designed to handle streaming data. We also need to know something about data management. So typically, the sensor data is going to arrive. How long do we want to keep the data? You notice with the energy dashboard, do we want to be able to have a summary of our monthly activity? If so, how far, how many months back do we want to go? So we want to see patterns over the last year. Do we want to go back further than that? So security, yeah, this is a big issue. You know, can somebody take over our Ring doorbell? You know, uh, you know, could somebody, you know, could you disrupt somebody's pacemaker? You know that you know, there's sort of the dark side. You know, could you mess up somebody's car or cause an accident by interfering with their car's sensors? Okay. We're going to get into this, as I mentioned, cloud computing for scaling and managing IoT applications. So again, that's where we're headed towards. And then, yeah, the data analytics. You know, how are we going to derive meaningful insights from that stream of data? And then a lot of low-cost ways. Dr. Phil Williams is going to show you how to play around with a Raspberry Pi. And again, very, I'm sure, they may not have a things board, but I'm sure they've got to have a, yeah. Yeah. So a Raspberry Pi 5, 16 gigabytes, you know, $120. Okay. And we mentioned, you know, finding a community. So this is where wanted to introduce you to some of the faculty, like Dr. Williams and Dr. Dagtus, that have worked with Internet of Things. But, you know, getting involved with, you know, finding a community, whether it's things board or, you know, finding other folks who are working with Internet of Things. And, yeah, and then, and just keeping abreast of technology, and then again, these are all these are sources coming from vendors, so you always get, you know, a little bit of advertisement for the vendor who's sponsoring the article. But anyway, this is just something to think about. I was going to say, if you're looking for interesting IoT projects, we do have contacts with the, this is the Arkansas, it's the Cooperative Extension Office. And you know, they are close by. If you walk out this building, head towards Jack Stevens, and then go through the parking lot to the next building that's on University. That is the Cooperative Extension, and they have some fascinating projects. And it's interesting. They do. Dr. Karen DeChico, who is sort of their, you know, chief technology officer, sort of drives the innovation. She is one of our graduates, and she helps to oversee some of the ways that the Cooperative Extension Service is using technology. And I'll tell you, Internet of Things is playing a big part. They have some really fascinating projects. We have 1 minute. So, for example, one problem they're tackling in Arkansas is feral pigs. Arkansas, you know, pigs get loose, and when pigs get into the wild, they become very, they can be very dangerous feral pigs. And so in Arkansas, they've been trying to figure out ways to round up the pigs. And so they have built large enclosures where they set up, and what they're hoping to do is they put some sort of food at the center of the enclosure, and they're hoping that a group of pigs will come by and, walk into the enclosure. And as soon as they can get as many pigs as they can in the enclosure, they want to be able to shut the gates. And that way the animal control can come out the next day and, pick up these pigs. Well, it turns out that this is where IoT and sensors are really important, because people don't want to watch these enclosures 24/7, because the pigs are not going to show up on a schedule. And the thing is, the pigs are really smart. If you close the gates too soon, the other pigs, quickly get the word, hey, avoid those enclosures. And if you do it too late, the pigs have come in, eaten the food, and left. So trying to use cameras, sound, other means to try to guesstimate, automatically at what point you have the optimal number of pigs in the enclosure, and then to be able to automatically close it and to then send the signal so that people know that the enclosure has been closed. And then, of course, you want to make sure you're closing it on pigs. You don't want to be closing it on a person, and you don't want to be closing it on deer. You're looking for pigs. And so setting up these IoT systems and combining them with things like AI to try to make sure that we are designing systems that can help get these feral pigs, out of the environment is very important to sort of the health of the Arkansas ecosystem. And so these are some of the really interesting projects that Cooperative Extension Services is working on. And so a lot of interesting use of of IoT and AI now for managing agriculture and biodiversity and our environment. So again, a lot of interesting projects out there. So hopefully you'll find one that you'll want to use for your data science project. So with that, yay, we are out of time. So everybody have a great afternoon. Enjoy the weather today and be weather aware the rest of the week.